section in Chapter 1 is 1.6 on radical equations. And when I made this video a couple years ago, it ended up 40 minutes long. That's ridiculous. I'm going to try to do it in under 22. That's my goal. Okay, so first of all, radical equations we're doing. We have been doing expressions. I've been asking you to do things like simplify something like this, right? And I just say simplify it. And even though there's an equal sign here, there's nothing on the other side. You're then going to simplify it and figure out a new way of representing this amount. But now what you're going to do, you're going to have equations. See, like this right here, you have a radical sign, so that's why it's a radical equation. And you're actually stating that it's equal to something else. And then we need to figure out, well, what is the number that can go into this x and this x so that both sides of this are equal? Okay, so it's just like equations that you've solved before, except now you have radical signs in them. And we solved equations before. What you always did is you did the opposite steps, right? So if it was a plus 6 step, you do a minus 6 step. If it was a times 4 step, you do a divide by 4 step. Guess what you're going to do when you have a square root sign? What's the opposite of square root? Squaring. So that's about the only new thing you're going to do here is you're going to do some squaring. So there's 3 different types of questions. We'll call them easy, medium, and hard, but we actually start with the medium one, and that's when you have only one radical sign. So the steps are, you're going to isolate the radical sign. You're going to get the radical sign all by itself, okay, and the radicand with it, of course. Then you're going to square both sides. That's what I was talking about. Doing the opposite of square root is squaring. And then you're going to solve, and then you're going to check for extraneous roots. And I'll talk about that in a second. Okay, let's try the first one here. So we need to isolate the radical sign. We need to get this square root of x all by itself. Well, in order to do that, we're going to have to get rid of this plus 6. And since it says plus 6, we're going to subtract 6. Now, you can either think of this as taking the plus 6 to the other side and it becomes minus 6, or you can think of it of subtracting 6 from both sides, whatever works for you. So I'm left with the square root of x on this side, and on the other side, x minus 6, there's no way of simplifying, it's just x minus 6. So there you go. Next step, square both sides. So we're going to square this side, and we're going to square this whole side over here. Alright, the square root of x squared. Well, those are opposite steps, right? If you take the square root of something and square it, you end up with just x. So that's very good. Now this takes a couple steps here. You have to do x minus 6 squared. You cannot do spreading the love, right? That's that common mistake people make. If it's x minus 6 squared, that's the same as x minus 6 times x minus 6. Now, some of you might start seeing the patterns, and you don't have to rewrite this, and you can just go straight to your answer, but you should be getting 3 terms here. You should get a trinomial. I'll keep doing it in this way, and if you pick up on what the pattern is on your own, good, but I'm not going to teach you because then I find a lot of people start spreading the love with these things, and you can't. So you'd have to do mountains and valleys. X times x is x squared, x times negative 6 is negative 6x, negative 6 times x is another negative 6x, and negative 6 times negative 6 is positive 36. We can combine the middle two, so you get x squared minus 12x plus 36. So that's what the right hand side equals when you square it. You get x squared minus 12x plus 36. Okay, now we get to a very strange part of the course, because what I'm about to talk about right now, I'm actually going to teach you in detail in a later chapter when we do quadratic equations. So it's kind of weird how they just kind of throw it in here. But what you have to be able to do now is you have to be able to solve a quadratic. A quadratic is when you have an x squared. And the way you do that, maybe I should have written this down. There, I did write it down. To solve quadratic equations, the first thing you need to do is you need to make it equal to 0. So right now it's not equal to 0. One side's equal to x, one side's equal to x squared minus 12x plus 36. And the second step we're going to do is we're going to factor. So we want to get everything to one side and we need to be able to factor it. Well, you want to keep your x squareds positive. Remember when we talked about factoring, you want to keep that first coefficient positive. So move this x over to this side, or if you want, subtract x from both sides. So if you do that, you'll have nothing left on this side. The x is gone. So you get 0 equals x squared. Now if you want, what I did is I subtracted x from here and I subtracted x from there. So negative 12x, take away another 1x, is negative 13x plus 36. Okay, this is always what you're going to do when you have quadratic equations and you're solving them. You want to make it equal to 0, like we did, and keep that first term the x squared term, keep it positive. Okay, second thing you're going to do is you're going to factor. So you have to be good at factoring, beyond good. You have to be awesome at factoring in this course. So you should be able to factor this. This is a simple trinomial. So you know this is one of the ones that you can go straight to the bracket, 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 bracket. X times x equals x squared. Two numbers that multiply to 36 and add to 13. I'm not going to keep writing the list. You should be able to figure it out that it's 9 and 4. So I put the big number first, the small number second, drag down that side. A negative times a what equals a positive? A negative times a negative. Okay, great. Now we need to introduce you to the zero product property. Okay, so here's the zero product property in a nutshell. If I told you that there's two numbers, a times b, and they equal 16, do you know either one of those numbers? No, you don't. One of them could be 1 and the other one could be 16. Or one of them could be 2 and 8. One of them could be 4 and 4. Or, you know nothing about those numbers. I mean, you know a small group of numbers it could be, but well, if we include decimals, there's even tons of numbers it could be. But what if I told you this? A times b equals 0. What do you know? If I tell you that there's two numbers and they equal 0, you know that either a is 0, or b is 0, or what's the other possibility? They're both 0. That's the only way this would work, right? You can't have two non-zero numbers, multiply them together and get 0. So one of them at least has to be 0. So the way you solve this is, you know, since there's x minus 9, and you're multiplying that whole factor by x minus 4, and you're getting 0, you know that either the first bracket, x minus 9, has to equal 0, or you know the second bracket, x minus 4, has to equal 0. It has to be the case that one of those brackets equals 0. Or maybe they both equal 0. And now all you do is solve this. Well, this is really easy to solve. You just add 9 to both sides. So you end up with x equals 9. How do you solve this one? Add 4 to each side. X equals 4. There's our answers, 9 and 4. We got two answers. Yes, this will happen sometimes when you're solving these. You get two answers. But you now need to check for extraneous roots. So the unfortunate thing about this is, sometimes when you get an answer, sometimes they're not actually answers. Like either one or both of them won't work. So we need to try it. So you won't need to write this for me when you do them. You don't have to write check and do it all, but I'll do it just to show you. If I put 9 in here, I get the square root of 9 plus 6 equals x, which is 9. Okay, the square root of 9 is 3 plus 6 equals 9. Yeah, that worked. Okay, let's check the other one. If I put the square root of 4 in there, plus 6 equals x, which is 4. That's 2 plus 6 equals 4. Did that work? No, it didn't. So this works. This is the answer. This here, that's an extraneous root. And we're done. There's only one answer. Okay, so that's a lot of stuff to worry about, because not only do you have these steps, I've also taught you like a whole other section that you're going to do later in this course about how to solve quadratic equations. It's kind of weird the order this book's set up, and you might say, well, why don't you just start with this chapter? But then it'd be some stuff that I'd have to teach you from chapter 1. So it's an imperfect system, I guess. All right, let's solve the second one here. The first step is to isolate the radical sign. We want to get this all by itself. Well, let's get rid of this 5. So it's minus 5. We'll add 5 to both sides. So you get 4, and then x plus 1 equals 8. What's this 4 doing to this here? Because we haven't isolated the radical sign yet. We need to isolate it. This 4 is multiplying. So let's divide both sides by 4. And you're left with the square root of x plus 1 equals 2. We've done it. We've isolated the radical sign. Now we're ready to square both sides. Hey, this one's going to be easier. Because when we square the left-hand side, the square root of x plus 1, all squared, just equals x plus 1. 2 squared equals 4. Hey, we're almost done. All I have to do is subtract 1 from both sides. You get x equals 3. Don't go to the next question yet. You need to check this. So again, you don't need to write for me check, but you certainly can if you want. But you do need to check it. So I get 4. Here's my x, so that's 3 plus 1 minus 5 equals 3. So that's 4 times 3 plus 1 is 4, minus 5 equals 3. Square root of 4 is 2, minus 5 equals 3. 8 minus 5 equals 3. Yeah, I see that it works. So we do have one answer, x equals 3. All right, that is the first type. Remember, that was the medium one. Now we go to the easy ones. The easy ones is when you have two radical signs. It looks harder. It's actually a little bit faster. So what you do here is you move the radical signs to opposite sides of the equal sign. Then you square both sides, solve, and look for extraneous roots. So we'll just do one of these. So here's our two radical signs. You want to get them on opposite sides. Which one would be smarter to move to the opposite side? Do you want to move the x minus 1 to the other side or the 2x plus 3? I would move the 2x plus 3 to the other side, and the reason for it is because of this minus. In that way, this will stay positive over here, x minus 1, and when you move this one over, it'll become positive 2x plus 3. If you do it the other way, it'll work, but this makes a little bit more sense. Great, we've done the first step. We've moved them to the opposite sides. Now we get to square both sides. And if you square both sides, you have the square root of x minus 1 squared, which just equals x minus 1, and you have the square root of 2x plus 3 squared, which equals 2x plus 3. Hey, this is like a grade 9 problem or something. So we got x's on both sides. We want to get all the x's to one side. Do you want to move the x over or the 2x over? Doesn't matter. I like moving the x because in that way we keep our x's positive. So all that's left on the left-hand side now is negative 1. 2x take away 1x is 1x, or just x, and plus 3. Hey, to get the x by itself, all I have to do is subtract 3. And I'm finished. Negative 4 equals x, or x equals negative 4. On to the next page. No, don't forget, you must check. So I have, if I look back up here, I have the square root of x, which is negative 4, take away 1, take away 2 times the square root of negative 4 plus 3, and hopefully that equals 0. Let's see. So first of all, we have the square root of negative 5 minus, you should be able to stop right now actually, but I'll just keep going for a second. 2 times negative 4 is negative 8 plus 3 equals 0. The square root of negative 5. What? You can't take the square root of a negative number? We don't allow that in high school. So you can't do this. You cannot get an amount here. So this does not work. So this is gone. This is an extraneous root. So what does that mean the answer is? There's nothing left. So the answer is that. What's that mean? It means no solution. You can write no solution, or you can write that symbol right there. Don't put 0. If you put 0, you're saying that it works if I put 0 in there and 0 in there, and 0 would not work. Okay, on to the third one. These ones are legitimately hard. Maybe not hard, but they take so much time. Like we got 2 questions left, and I'll be lucky to do these in under 10 minutes total. Okay, so here's the steps first of all. You're going to move the radical signs to opposite sides and square. You're going to isolate the remaining radical sign because there's still going to be another one left and square again. And then you're going to check for the extraneous roots like we always do. Alright, so we're going to get the radical signs to opposite sides. We already have that. We have them on the opposite sides, and we're going to square. You could do that right now, but why don't you make it just a little bit easier for yourself and combine, or not combine, but deal with these 2 constant terms here. Put those together, like either move the 7 over or the 5 over. Which one you want to move? Well, you know me, I like keeping things positive. So I'm going to take away 5 and take away 5. So what I have is 2 plus the square root of 3x equals the square root of 5x plus 4. See, what makes this question way more work than the last question is this darn 2 here. Because now the next step is to square both sides, and unfortunately, on the left-hand side, it's not so easy. Because what you have is 2 plus the root 3x all squared. You can't spread the love here. Don't do it. What I have to do is 2 plus the square root of 3x multiplied by itself when we square. And we have to do mountains and valleys. So this is a fair bit of work. Okay, 2 times 2 is 4. 2 times the square root of 3x is 2 root 3x. Root 3x times 2 is another 2 root 3x. Root 3x times root 3x is, you should be able to get this quickly, root 3x times root 3x is just 3x. Okay, we can combine the middle 2 terms. 4 plus 2 root 3x plus another 2 root 3x is 4 root 3x plus 3x. So that's what we get on the left-hand side here. We get 4 plus 4 root 3x plus 3x. The other side's easy. It's the square root of 5x plus 4 all squared. That gives us 5x plus 4. Okay, now what we need to do is we need to isolate the remaining radical sign. It's kind of like a type 1 problem now. We got to get that root 3x all by itself. So we can do a couple things at once. We could subtract 4 from both sides. We could subtract 3x from both sides. Let's stop there and see what we got when we do that. So when we do that, we're left with 4 root 3x equals, that's gone, right? That's gone. 5x take away 3x is 2x. And 4 take away 4 is 0, so that's gone too. Okay, that made it a lot easier. You could square both sides right now, incidentally, and you just make this 16 times 3x. But I like to actually isolate the radical sign. So what I'm going to do, since this is 4 times root 3x, is I'm going to divide by 4 and divide by 4. That leaves me with root 3x on this side. And on this side, I get 2 over 4x. That's 0.5x, or you could write it as 1/2 x, or you could write it as x over 2. Same as 1x over 2, right? 1/2 x. Okay, we have gotten all the way down to isolating the remaining radical sign and square. We're ready to square now. On the left, root 3x squared is 3x. On the right, x over 2 squared, this is a spreading the love question. You can spread the love there. So you get x squared over 4. Okay, maybe I'll rewrite this over here. As I said, this is a lot of work. When you're solving equations and you have fractions, what we like to do is multiply everything by the lowest common denominator. In this case, it's 4. So we multiply by 4, we end up with 12x equals, these cancel, x squared. Okay, remember our rules when we're solving quadratics? Because that's what we're down to. We're down to a quadratic. We need to make it equal to 0 and factor. So this is not equal to 0 right now. How do we make it equal to 0? Do you want to move this one over to the right or the x squared over to the left? Don't move the x squared to the left. It'll become negative x squared. Move the 12x over. So you get 0 equals x squared minus 12x. And now a lot of people get confused because they say, well, that's not a trinomial. I can't factor it. It's a binomial, but it's not a difference of squares. I can't do. What's the first type of factoring you should always try to do? Take out a greatest common factor. And there is a greatest common factor here. What is it? X. So we take out the x, and we're left with x, because x times x is x squared. Take away 12, because x times 12 is 12x. Okay, we're done. Now, there's two factors here. One factor is the x. I'll put it in brackets if that helps you see it. The other factor is x minus 12. We're multiplying them together and getting 0. So we know that either this first bracket, the x, is equal to 0. Well, look, there's an answer, x equals 0. Or the second bracket, x minus 12 equals 0. And if that's the case, we can solve that very quickly by adding 12 to both sides. We get x equals 12. So here's our two answers, or our two potential answers. Now we need to check them. Boy, I don't want to do that, and boy, we don't even have any room, but I guess I can do it quickly. If I check this first one, I might do a couple steps at once. I have 7 plus 3 times 0 is 0, and the square root of 0 is 0, so I just get 7 on this side. Equals, if I put 0 in here, I'll get 5 times 0 is 0, plus 4 is 4, and the square root of 4 is 2, plus 5. And that's true, so this one definitely works. If I try 12, I put 12 in here. 3 times 12 is 36, and the square root of 36 is 6. So I get 7 plus 6 on the left-hand side. On the right-hand side, I get 5 times 12, which is 60, plus 4 is 64, and the square root of 64 is 8, plus 5. That's true. 7 plus 6 is 13, 8 plus 5 is 13. Both of these answers work. There's two answers that work here. You could either put 0 into both of these spots and the equation works, or you could put 12 into both those spots and the equation works. Alright, this last question is so long, I'm tempted to not even do it. It's probably because of this question I'm going to go over my 22 minutes and end up at 26 or 27 or something. So we do the same steps. We want to get the two radical signs to both sides, and that's already done. And now we're going to square both sides. So here we go. On the left, that's no problem whatsoever. You end up with 5m minus 9. On the right, I better write it over here so we can do it. You're going to square this. So you're going to multiply it by itself. And you're going to do mountains and valleys. So the first mountain is square root of m plus 4 times the square root of m plus 4, which equals m plus 4. Next one is square root of m plus 4 times 1, so it just equals the square root of m plus 4. Then I do 1 times the square root of m plus 4, so I get another square root of m plus 4, and then 1 times 1 is 1. I can combine the two middle ones, so I get m plus 4. I could actually combine the 4 and the 1 too, couldn't I? So I get m plus 5, and then I get one of these plus another one of those, so I get 2 square root of m plus 4. So I write all that in here, m plus 5 plus 2, the square root of m plus 4, and my next job is to isolate this radical sign. Okay, so we can take away an m, and we can take away a 5. And what that leaves us with is 5m take away m is 4m, negative 9 take away 5 is negative 14. This is gone, and we're left with 2m plus 4. That's 2 times, so I'm going to divide this side by 2. I'm going to divide all this side by 2. You can do that. Because you can divide both those terms by 2, you can do it. But you have to be able to divide them both by 2. And I can divide that by 2 and get 2m. I can divide that by 2 and get 7. This is gone, right? 2 divided by 2 is just 1. So m plus 4. Okay, we isolated the radical sign. Now we're ready to square. Alright, so this is not spreading the love. You'd write it out twice. Some of you probably picked up in the pattern. I said I wouldn't, but let's do it. 2m squared is 4m squared. Now to get the middle term, you go 2m times negative 7, which is negative 14m, and you're going to get 2 of those. So you're going to get negative 28m. And negative 7 squared is plus 49. If that was too fast, too confusing, then do this. 2m minus 7 times 2m minus 7, mountains and valleys, and you're going to find you get this. Okay. On the right hand side, m plus 4, square root of m plus 4 all squared is m plus 4. Okay, solving a quadratic, we got to get it equal to 0 and keep this m squared term positive. In other words, get rid of these ones on this side. Subtract m from both sides, subtract 4 from both sides. And if you do that, you will have 4m squared minus 29m plus 45 equals, this is all gone, 0. Next step is to factor. Oh my gosh, what kind of factoring is this? This is Bobby Bridge. There's no greatest common factor. We'd be looking for two numbers that multiply to 4 times 45, which is 180. This is crazy. And they have to add to 29. So 1 and 180, and 2 and 90, 3 and 60, and 4 and 45, and 5 and 36, and 6 and 30, and 9 and 20, 10 and 18, and 12 and 15. This is a terrible question. Which of those add to 29? Those ones. So remember, we're going to decompose. So we have 4m squared. We have to get negative 29. We better subtract both those numbers. So minus 9 or minus 20, whichever one you want. Minus 20m, minus 9m. You can put those in either order you want. Plus 45 equals 0. Pair them up. Greatest common factor of the first pair is 4m. That leaves you with m minus 5. There's a minus sign. Greatest common factor of the second set is 9. That leaves you with m minus 5, right? Negative 9 times negative 5 equals positive 45. It worked. We got the same thing in both. So take that out as one factor. The other factor is 4m minus 9, and it all equals 0. Now, since that equals 0, we know that out of the first bracket, m minus 5 equals 0. And that's easy to solve. Just add 5 to both sides, and you get 5. Or we know this bracket, 4m minus 9 equals 0. This is a little more work to solve, but not much. Add 9 to both sides. 4m equals 9. Divide by 4. M equals 9 over 4. Or if you want, 2.25. And we're done, thank gosh. But we're not. Now you'd have to check those answers back in here. You'd have to put 5 in the both. Well, we could do the 5 very, very quickly. So we'll do that. We'll check the 5. If you put 5 in here, you get 5 times 5 is 25, take away 9 is 16, and the square root of 16 is 4. On the other side, 5 plus 4 is 9, the square root of 9 is 3, and we have the plus 1, it works. So we know for sure that this works. The sad, sad news is you would need to check 9 over 4 as well. You need to put 9 over 4 into both sides, and you need to check if it works. And I don't want to do that because it's a fraction, and it's going to add so much time to this video, and it makes me upset. So what are we going to do, people? I could leave it for you as something to try on your own. I will tell you, it doesn't work. 5 times 9 is 45 over 4. Do you see how I'm doing it anyway? Equals, okay, you need common denominators here, so you have 9 over 4 plus 4 over 1. Common denominator is 4, so multiply this by 4 and multiply the top by 4, you get 16. So it's 25 over 4 plus 1. Need common denominators here, so you have 45 over 4 minus 9 over 1. Common denominator is 4, multiply that by 4, multiply the top by 4, you get 36. 45 take away 36 is 9 over 4. You can take the square root of 25 over 9, just take the square root of 25, which is 5, take the square root of 4, which is 2, and add 1, we're almost there. You can take the square root of 9 over 4, it's 3 over 2. And does 5 over 2 plus 1 equal 3 over 2? No, it's impossible. 5 over 2 is already bigger than 3 over 2. Adding 1, or if you want, adding another 2 over 2 is going to equal 7 over 2. These are not equal to each other. And so this last one down here, that is an extraneous root. You only have one answer. That's just ridiculous how long that question took. I don't think you're going to have to do any quite that long, but then again, I might be wrong.